Hey guys, welcome to episode 8 of the Peer-to-Peer Network Coding session. In the last episode, we finished polishing the bootstrapping process of the network node, and that means that now we can continue with the other features that we added at the UI. So one thing that I'm going to do now is this. I'm going to rename this workspace and I'm going to call it peer-to-peer network demo. Okay. Peer-to-peer network. No need for dashes, I believe. Okay, so I'm going to start recording this because then I'm going to turn it into a plugin itself so other people can use it. Because it's the only place where I'm going to have these definitions, these two plugins. Okay, so coming back here, what we have enabled in the last few episodes is the ability to have permission network or public networks. These are open networks, anybody can join. Permission networks are networks that only if you have been granted permission by the user that owns the network, and the user that owns the network is the user that creates a permission network at their user profiles. Okay. Then you're going to be able to join his network. So this means that besides the public peer-to-peer network, the mainnet and the testnet and whatever other public network we create, every single user will be able to create a peer-to-peer network for themselves or a group of friends or a group of people they want to work with. And they just come here at their profile and add one permission network and defines via this structure which profiles they want to have access to this network. Okay, so we haven't worked on this in the implementation of the permissions. We're going to do it, but not at this video. But this enables anybody to create their own peer-to-peer network, and that's it. So, and also it allows that anybody else can set up a peer-to-peer network node and join publics and private networks created by anybody else. That means that a team of people can team up and between them run a super algos private network, maybe of 10 network nodes, and they can coordinate themselves, maybe 100 or 1,000 people in a private way without anybody knowing that they are even doing that. Okay? And I think it's a pretty cool idea and quite powerful. So that is permissions peer-to-peer network. But what I wanted to work now is on this part of the definitions where we have a peer-to-peer network node, which by doing this, we're referencing which network is going to be belonging to. I want to work on this, on the network services that this is going to run. So by adding a network service, you are signaling for your peer-to-peer network node which service do you want this node to run and which service you don't want it to run. So just put the ones that you want to run, and the ones you don't want to run, you just don't put it here. So what I'm going to do now is go to the network node and code this, implement this, because as of today, the network node only knows or is running a social graph service and a trading signal service, but without uh, asking anybody, just do it. So I'm going to make a separation in the code so that this can be done only when the profile has, or the network node has, that information. So let's go back to the code of our network node that is here. Okay, so I will be closing some stuff that I don't need, like this, and this. Here we have our stack. This is the network node application. The equivalent to the desktop app. Probably I should call it network app. Well, in the same way, I should call the task server task app or something like that. I'm trying to get things standardized so that they are easier to understand. Okay, so this is the network app. Let me call it network node today. Well, maybe I can change that. Let me see. This is inside this folder, and we have a desktop app network node. Okay, we're going to change it. So this is going to be called now network app. I always have to make sure that I don't have anything uncommitted. Okay, so now this is going to be network app. Network app. Well, and just like that, now it's network app. In fact, okay. So the network app, perfect. Okay, so these are the two functions we are executing when this is run. One is making this setup, including the bootstrapping process, the discoveries of the nodes that we can connect to, and the setup of these peer-to-peer network peers with live connections to whoever we can connect to. Okay, so then it comes the services, but there are like, these are like network services. Oh, but we already call these network services here. Yes, network service. Okay, I'm going to separate this into another function that I'm going to call Not sure it is an asynchronic function though. Function setup network interfaces. And this is going to do this part of the job. Okay, network interfaces. So how I remove this tab? Okay. Setup network interfaces is going to start the WebSockets and the HTTP interface of this network node. And this services is going to be setup network services. Setup network services. Okay, we're going to solve this to do now. And probably we are going to remove this comment because it's not needed. So we are not really having this, nothing inside this guy. Social trading. Okay, so somehow we have to tie this thing, tied up a little bit this stuff. Okay, so here this storage is probably something that we want to have inside this other service. So let me do that. When we initialize this, we are going to initialize the storage. And that means that the storage, instead of being an object here, that doing nothing here, is going to be an object from here. So at this object, we are going to have the social graph service, which is exactly this one. Okay. The two interfaces and the other supporting objects, including the bootstrap process. And I'm not sure that we need the bootstrap process to be stored, because it's just a process that runs and that's it. So let me check out this. Where is this? Okay, so this shouldn't be something that we store. Also, we're going to do this. We're going to just run this stuff, run the process, not going to initialize. Okay, so the bootstrapping process, we're going to change this and put a run function on it, meaning that this is going to be run, no finalized because it's stateless, and it looks better like this. Okay, so okay, so we have less object here, network, peers, a node, the two interfaces, and the only service that we have. Okay, so the service is defined and initialized here. And now we are going to check that we do have to run this service. Okay, so what we are going to do is if peer-to-peer network node okay, so with this we are going to check this peer-to-peer network is it's not this guy, it's peer-to-peer network node, which is essentially this guy that represents the node. If we put node here, so this represents this node, and then we can check if it has this guy, network services. Okay, so now I cannot do that exactly in this way. So what I'm going to do is that I'm going to iterate this array of nodes. So network service is going to be this guy. Then I'm going to make a switch. Network service dot type case social graph. So only in this situation I'm going to do this stuff. So let me see if I am doing the right thing. The node has an array of no. This node can have only one child network services, and that node that is called network services has an array of network services. No, it's not that way either. Why I'm so confused? This node can have one of these three stuff. Oh my god. What a waste of time. I was doing it right. Okay, so I was doing it right. I got confused because the name is plural. So I thought it was an array because everything that has plural noun is an array here, but in this case this is a node. So if this is undefined, because it could be undefined, and this dot is undefined, then we are going to initialize this and put it to run. Okay, and later we will do the same for trading signals, but first I'm going to reconfigure this stuff so that it goes according to that. Okay, this is good, but the next problem is that I'm going to get out of this because I don't need it. The next problem that I have is that via WebSockets we are going to receive messages and they are going to come through the WebSocket interface, and they are going to enter, or at some point move forward to the next layer. I'm trying to find where that happens. Okay, let's organize this code. So This is the WebSocket interface on message. It can be a handshake or a request. If it is a request, this is being forwarded to a client interface. A client interface. Let's see who is that. Client interface. Okay, social trading. This is going directly to social trading. But how do we know that this is a social trading kind of request? We don't really know. So at the header of the message, we need to receive something that tells us that this is a social graph request, okay? Okay, so that's what we're going to do now, and this is the most delicate part, because this is, and the second, we need only to forward this if we have already started the social graph stuff, okay? So we are here, WebSocket interface. Let's return to the network app. We have this social graph service, okay? Social graph service. Probably the social graph service should be the one having this client interface and blah blah blah. This is not something that should belong. Yes, we're going to move this client interface and peer interface are social graph stuff. So we're going to move it from this module to the social graph module. Then we're going to put it here or here. Okay. So this is a major movement because we have to be careful. But I like it because it's going to clean this stuff a lot. Okay. So these two guys are not part of this show. They should be here. I would like to know, or I would like to have, first I'm going to have this guy down here because this is part of social graph project. So here I have network and here social graph, okay? That's how we are going to get organized better. So this guy, find me this guy. So they have an initialize, but it's never called. So I will have to start tidying this a little bit better. So what we're going to do is instantiate these modules here and initialize them here. Good. And this is wrong because we need to finalize all these once we don't use it anymore. And in particular the storage, we need also to undefine it. Okay, so here we do first the finalize of everything, and here we do the initialize. Okay, so now this is getting better. So this is not more anymore at the WebSockets, which is a good idea. But then that means that this guy from here, we will need to change it because we are receiving a message here. Okay, we are receiving a message that has a message header, and we will assume that the message header contains a network service. Okay, so even though it is segregated by client or peer, what we will do is the following. Um, network service, network service, and here the possibilities are case, social graph. Okay, is the number one possibility. So it can happen two things: that the service has been initialized, or that the service has not been initialized. So we need to ask that in order to send that request forward. So because this is stored at network node, and we have to call it network app. Okay, there will be a refactoring in the middle of all this. Okay, no problem. It doesn't seem that it's going to fail in any way. Just refactor network app. Okay. So again, we have this network app, and our service is social graph service. Okay. So what we're going to do is to use this and ask if network app social graph service is not undefined, meaning that it's a service that is running. Then we're going to do this, otherwise we will respond with an error to the caller and say that, you know, social graph network service not running or not available. Okay, social graph network service is not running, and it can be not running mostly because it's not configured to be running. Okay, but if it is running, then what we're going to do is what is in here. We're going to go to not to this object client interface, but the network app. Hold this guy, client interface, and send the stuff. Okay, and we have a switch here because we are also going to have another case where the message is trading signals. Okay, the message, no, the network service is trading signals. So in this case, we are not going to do it right now, but we are going to leave it there. Okay, so for sure we will need a break there. So this is if it is a network client. If it is a network peer, we're going to do a very similar stuff. But instead of calling client interface, is going to be the peer interface. And the rest of the stuff is essentially the same. Okay, so what did we do? We are assuming that it's going to be coming a network service defined at each message. Okay, we are going to control that we have this. Because it can happen that somebody sends a message without that. Okay, so this is what is going to happen. And we haven't changed that much. We just move the definition of these objects into social graph. Okay, so they are initialized here, and that is why we can send that stuff there. Okay, so for this to work, we will need whoever is communicating with the peer-to-peer network node via WebSockets. We will need them to send that parameter. So let's have a look at this. We will need this module too. This is the client of the WebSocket interface. Okay, this is the guy who is speaking to us. So when this guy sends a request, we need to add which is the network service we are trying to reach. Okay, so let's analyze this code a little bit. Step 1 response. This is the handshake procedure. Send message. Okay, message type request. Here it is. Message type request. We are going to add here the network service that we are trying to reach out. Then this is social graph. Okay. So let's see where else do we have this request or message type. Okay, this is the handshake. We don't need to specify that stuff. This is handshake. Okay, so every single request for now, we are going to send it with this network service specified here. Okay, because all the applications we have today are related to the social graph. All the ones communicating via WebSockets are related to social graph. Okay, so in this way, we organize this part, that when this exists, then we instantiate this service and we allow the messages to go through. But for that, we need that the sender specifies which network service they are sending the message to. So that means that the network node is independent of the service. It can be running from 0 to any number of network services and still providing a low-level infrastructure of communication, in this case via WebSockets and also HTTP. Okay, so we're going to try this out now and see if it is working. How are we going to test this? Well, first we're going to run it to see if it crashes. So let it run from here. cannot. Okay, there is a require. Where is that? Network GS require network root. Network root, it might requires network node and is now network app. Okay, again. Well, initially it's running. Okay, I guess we will have to test this by running the desktop app, for instance. Maybe I should add something here that tells that social graph is running. It would be consistent with the other logs that we have. So I'm going to copy this, only one line. So here, social social graph network service running. Let's check it out. Okay. Okay, now I'm a little bit troubled by this, considering itself that it's running when it's not yet running. So what is going on with this? Where do we have this? I don't think we even needed that. Or and it's not SuperAlgos network. So here we are going to network app is running. Okay, I like it. Okay, so how do we test if this is actually running? Mm. what I'm going to do is this. I'm going to come here at the package JSON and see, because I don't remember which is the script to test the desktop app. Start desktop. So I will get a new console. And I will do an npm run start desktop react. And I already have this running. No, let's have this running. Okay, then I will start this. But the problem is that this is going to start a network node also. So I'm going to stop this guy and let everything run from here and see what happens. Okay, there's a problem here. What is the problem here? Bootstrapping process initialize. Okay, I changed this bootstrapping process, but only assuming that it was executed at the network node, and it's not the case. It's execute and a few other places, and now it's called run. Okay, so I need to change that for run. Okay, so this guy, we're going to turn it off and close. Yes, close. Yes, close. Yes, and try it again. So our network node is okay. The backend is saying that it's okay. And this guy looks like it's okay. So let's hope that this all works. And it would be a very good signal. There it goes. Okay. Yeah, perfect. Amazing. So all this is working. That means that all the things that we have been touching so far are working. So I'm just going to commit this. That is social graph as network service implemented. Okay. And you go. Okay. So this was another cool session where we implemented something that we already implemented at the UI, that was the possibility to specify which is the network service we actually want to run and which one we don't want to run. That opens the door to having multiple network services at each peer-to-peer network node, reusing the communication infrastructure of the node, the capacity of the node to connect into other nodes, forming a network, and it's super cool. At the next video, we are going to do something similar for the trading signals network service, and it's going to put it to work in this exactly the same way. I don't think it's going to be hard because all the pieces are more or less in there. Okay, so that's all for now. Thank you for watching again. See you next time. Bye.